I'm Tim. I'll be your theory coach. I'm going to walk you through the most difficult areas of the Math Methods course step by step.
Hi, I'm Phil. I'm going to be your exam coach. I'm going to show you heaps of examples and together we're going to go through some of the hardest past exam questions.
Let me give you a little conundrum. Let's pretend you're walking down the street one day, minding your own business, then suddenly, out of nowhere, and for no apparent reason, you get hit by a water bomb. You stop, stunned, only to be hit again. Now at this point you've got three choices. The first is to get mad. The next is to cry. But you decide to go for option number 3, to get even. So you look around to find whoever was responsible for this vicious hate crime. You look up, but all the windows of the building are closed. You can't see anyone. How are you going to track these guys down? Now at this point I think most people would probably give up, but the true genius would get out his maths books and determine the location of his attackers by using trigonometry and circular functions. First you need to work out the angle that the water bomb struck you from. Now if we look closely, we notice the head move backwards and to the right. Backwards and to the right. Backwards and to the right. We determine that this effect could only be caused by a water bomb hitting at a 45-degree decline. We then decide to work out how far away from the building we are. We take meter-long strides from where we were hit to the base of the building, and we work out that we were 20 meters from the building. Now we have enough information to work out which floor our attacker was on. We know the adjacent side length of the triangle and the angle. So to find the opposite side length, we use the tan function. This is from SOHCAHTOA that you covered in year 11. So we know that tan of 45 equals opposite over 20. So our opposite side length is 20 times tan of 45, which is just 20, since tan of 45 is 1. Since the floor is 4 meters high, we know our attacker was on level 5, i.e. 20 over 4. This is an example of trigonometry and circular functions. This kind of maths can allow us to do a number of things. Firstly, trigonometry allows us to do a range of surveying type questions. For example, let's pretend you are standing on the street looking up at a church steeple. If you knew the angle at which you looked at the steeple, we could use the tan function to determine exactly how high the steeple is. Or if you wanted to build a flying fox from the top of Eureka Tower to the Arts Centre, you could measure how far the buildings were apart and then use the cosine function to determine how much steel cable you would need. Finally, if you were standing at the bottom of a hill and you knew the angle of the slope and how tall the hill was, we could use the sine function to determine the length of the slope and, in other words, how long it would take for us to walk to the summit. Sine and cosine functions are also used to describe natural occurring phenomenon, such as the swinging motion of a pendulum. This swinging movement or pattern can be represented by a wave. We call this motion an oscillating wave, which means that it simply moves back and forth between two values. Other examples are light and sound waves. These functions have characteristic wave-like patterns when graphed. It turns out that there is a difference between noise and music, and that music is a positioning of waves according to trigonometric functions. So rock and roll equals trig functions. Mozart equals trig functions. Country music, well, that's just still crap. Over the next series of videos, we're going to introduce you to, walk you through, and prepare you for the hardest sections of trigonometry and circular functions questions on the exam. In this video, we're going to have a look at how trig functions apply to part 1 of the study design, to functions and graphs. Then in video 2, we're going to have a look at how trig functions apply to part 2 of the study design, in algebra. Then finally in video 3, we're going to look at how trig functions apply to part 3 of the study design, to calculus. So let's jump straight into it and start by having a look at how trig functions apply to part 1 of the study design, to functions and graphs.